Prior to the 1800s, most naval engagements were conducted at a range of between 20 to 50 yards. Now, similar to the notion that duels were conducted on a regular basis, actual long-range firing from naval vessels was a myth. The term naval ballistics is a general term for the calculation, use, and development of ballistics within the maritime field of warfare. Due to the necessity of rapidly calculated variables, naval ballistics have greatly contributed to the technological advancement of modern-day computers. All of the facts listed during my speech have been obtained by various conclusive sources. All of them are cited in my outline. Naval ballistic calculation has changed greatly over the past 3 centuries. The advancements in naval ballistic calculation have greatly contributed to the development and widespread use of modern computers. So the concept of naval ballistic calculation has not always been so technical. Prior to the American Civil War, naval engagements were usually conducted at comparatively close ranges. This was done for many reasons, but primarily to ensure that the ship's single-shot cannons were used most valuably. During the Civil War, the development of larger naval guns became a game-changer in the world of maritime warfare. These bigger and more powerful guns had much longer range and the ability to engage targets repeatedly with greater speed and accuracy than old smoothbore muzzle-loaded cannons. These longer ranges allowed vessels to be further apart, so ballistic estimation became more of a problem. In order to hit a vessel, the offender had to relatively aim the weapon, fire, and correct for the distance that was missed. Obviously, a more accurate method of ballistic trajectory calculation was needed. So between the American Civil War and the 20th century, numerous advancements in fire control took place, such as telescopic sights, optical rangefinders, and the use of plotting boards to manually predict the position of a ship during an engagement. Around about 1905, the mechanical fire control aids began to become available. These devices were simply mathematical tables and rapid calculation aids and charts in order to assist with human calculations. The problem of rapid and accurate maritime target acquisition became imperative with the inception of the First World War. Right after the Industrial Revolution came about a device called the rangefinder. This device was an electric and mechanical apparatus designed to receive multiple inputs and instantly give an output. For example, multiple seamen could individually be assigned an input task. So one would receive an input, say one would receive a target range, another would input wind, etc. So this device, the rangekeeper, could conduct target tracking, target position prediction, gunfire correction. This device proved to be invaluable in naval warfare in World War I. Originally, a computer was a person who had the job of performing mathematical calculations. With the implementation of rangefinders, and as those rangefinders became more advanced, those devices became so encompassing that they no longer were limited to the term of a rangekeeper. These devices then became known as computers. In the early 1930s, the Ford Mark I ballistic computer established the use of the first mechanical computer in naval warfare. With this computer came the development of great advancement in naval ballistics, including mechanical main gun servo controls to eliminate human inaccuracies. And in World War II, the use and input of radar retrieved data allowed for greater accuracy in use of these computers. So now that ships could accurately obtain ballistic data in order to destroy a target, the new problem of sharing that data among Allied vessels became an issue. By the end of World War II, it became apparent that being able to share this target data between vessels was extremely important. Similar to the beginnings of ballistic calculation, it can be done manually or, in the data sharing case, verbally over the radio. Target data could be relayed over the radio, but this process was slow and complex. After the end of World War II, the U.S. and its allies started working on a system that could automatically calculate and share naval target and ballistic data. In the next few years, the U.S. Air Force built a system for the similar purpose that went by the name of Project Charles. This became the largest computer ever built, taking up 2 whole floors of an office building. Along with the high interest of code-breaking computers later in that decade, the following years brought out major advancements in computing, including the implementation of a transistor-based computer which are now the basis of what we consider computers today. In 1956, the Navy developed their Tactical Data System, or the NTDS for short. This system was based on a transistorized computer with a wireless data link, allowing other ships' computers to share the data regarding the battlefield, and then they could prioritize accordingly. NTDS was the inspiration for the Aegis Integral Naval Weapons System, now in use on Navy ships today. In conclusion, today we've discussed the concept, the history, and the development of naval ballistic calculation. Even though we may not consider the use of our cell phones and our computers and our technology in our everyday lives, we don't always correlate the development of these devices with items in the field of naval warfare. Since the 1800s, naval ballistic calculation has taken leaps and bounds of technological advancements, from early short-range human-operated cannons to today's modern, digitally, fully autonomous weapon systems. We can be sure that such technological advancements will only continue just as rapidly for years to come.